After he finished his PhD at the Faculty of Enology at Bordeaux University. His research program was the key flavor components of Armagnac and Cognac brandies, which most definitely sounds much more interesting than smoke taint. Eric is a specialist in developing new analyses and conducting applied research programs and investigating wine flavor and taint issues at ETS. And he's been there for some 20 plus years working on that. He's perfectly positioned to tell us about what's happening with smoke taint analysis. And as you will discover, even after 20 years, he still has a French accent. Thank you, Eric. Take it away.
Thank you, Sean. Yes, that's unlike the Australian one that doesn't completely disappears with time, right?
I have an accent?
Okay. Thanks to Anita, by the way, it was an excellent presentation. Let's share my screen. Where did it go? Share, okay. Okay. Okay, I'm showing everything now. Okay. Okay, let's go back to the beginning. Okay, 3 parts in that talk. First one, a recap of the smoke markers in grapes and in wines. Some war stories about the last harvest and the status of current testing options for wine. Okay. So I'll go fast for the markers. Anita reviewed that, so you've seen that before, a model of lignin. Lignin is a main component of wood and straw. When it burns, that's a phenolic polymer, and when it burns, it gives a smaller building blocks, basically, that become volatile and cause a good part of the problem, giving smoky odors. When it breaks down here, it gives guaiacol. Breaks down here, it gives 4-methyl guaiacol, and that's the main markers of smoke taint that has been proposed for the past 12 years or so. There's more. Cresols, 3 of them, phenol itself, and 2 syringols. All these compounds, when they are absorbed by grapes, tend to become bound to sugars. That's a defense mechanism, most likely. Binding them to sugars make them water soluble, and they can be dumped in the vacuoles where they won't interact with vital metabolic processes from the cells. We all know that smoke has some toxicity. We use it to keep fish and meat for that reason. So by summer of 2020, we were ready because we had an analysis ready for selected glycosylated markers. We had capabilities, analytical capabilities like never before. The Vinquery lab had closed also, and we got their GCMS. So we were ready. But it was 2020. So by mid-August, the Hennessy LNU complex fire started. It was big and it was close to us. Basically, about 1/3 of Napa County burned. Viewed from the Napa Valley, you could see that it was big. And if you didn't see the smoke in the first days, when the sky turned red, and we looked like we were in the middle of the Blade Runner movie, that was quite eerie. Quite quickly, we got actually overwhelmed with samples, swamped with samples, mostly grape samples. And the reason was that insurance companies were requesting grape tests to basically, if you were submitting a claim. So all in a sudden, we got just swamped with samples. Good news that COVID had something good because there were no weddings happening, and guess what? We could rent freezers and fridges easily. So we could store thousands of grape samples in the right conditions for analysis later. But all our good work about extended volatiles panel or glycosylated markers panel, well, it was forget about it. The only option to get a fast throughput at this point was to focus on the main two markers. So that's a table that I was showing before the fires regarding the pros and cons of grape versus microferment tests. And microferment is something that's been more and more popular in recent years for good reasons. The very good things that you can taste them and get an idea of what will happen with production wines. Be careful, because when it's not obvious, when you're borderline, it's still, you can miss it very easily. And the best is a combination of doing the microferment and analyzing that microferment. The good thing about grapes is that you have usually a much more immediate answer. You bring grapes to the labs, and within 1 day, 2 days, you get some answers about your risk of smoke taint materializing in wine. Well, all of this was through the window. Our turnaround time for grapes at some point became 2 months. So to expect results for harvest decisions, again, forget about it. The only good reason was to get numbers to give to your insurance company. Okay, so we still expect, by the way, that insurance companies will keep asking for guaiacol and 4-methyl guaiacol as the default test. Thanks to Anita, by the way, and UC Davis, during the fire disasters, insurance companies started to accept results, analysis of microferments. Okay, not only grapes, and that's a good thing. Okay, but it was 2020, and if we thought that the situation was bad, then the glass fire happened. And end of September, if you were looking at the fire activity map on the evacuation maps, it was looking like this. Okay, so basically St. Helena completely surrounded by the fires. And at that point, we decided to evacuate the lab. And we realized that, well, okay, we could evacuate the lab in an orderly fashion, but we had thousands of grape samples in freezers and in fridges that were there and that could be lost in case of power outage or just if St. Helena started to burn. So we got help, and thanks to the folks at Copper Cane and Walsh Vineyard Management, basically we spent the afternoon and most of the night evacuating fridges loaded with grapes. There was no way that we could just empty them one by one in an orderly fashion and store the grape sample somewhere else. We said, okay, let's move the whole fridges. So some thoughts about preparedness for the next events. So Anita was talking about the need for more training for sensory evaluations. There's clearly a need for just facilities for small scale fermentation. So UC Davis gave, by the way, there's a YouTube video on how to do it, but we had so many growers, just new clients, they had no clue what to do. How do I set up an account? How do you do analysis? How can you do microferments to me? No, we couldn't. There's clearly a need of a place where people can bring their grapes and have microferments prepared. Additional analytical capabilities, UC Davis, other labs stepped in also to help with that, but it wasn't insufficient. It worked well for us to work with a lab in New Zealand where we could send microferments on wines. And this lab we knew was exactly on the same page as us because we shared the method, we sent QC samples, etc. They were doing exactly the same thing. Probably a need for cold storage. As I said, we are happy because we could rent more cold storage facility. It won't be the case every year. What about, and I was saying even before the glass fire, I was telling people, okay, keep backup samples, and people were asking me why. Well, again, you look at that, and you understand why. Okay, basically, it was a close call. We could have lost thousands of samples. So current testing options. Again, in 2020, both on one thing, by the way, to get this out of the table, one thing that we don't do is analysis, global measurements of total or bound compounds. We have chosen not to do that. We are not sure what these tests actually measure. We focused on measuring directly selected glycosylated markers, and we're on the same page with the AWRI for that. The only thing is that by 2020, we had slightly different lists of compounds, and we are not using the same units before because the reference compounds, the pure reference compounds, did not exist. Okay. So by the way, so during the fires, actually, while the fires were raging, we worked behind the scenes and with the Wine Institute, Technical Committee, the AWRI, and large wineries to put money in common and to first agree on a list of glycosylated markers and then have the pure reference compounds made, custom made, and their isotopic analogs also prepared so that we can do a quantitative analysis. So that's the list that we agreed on, and it may look familiar because that's the AWRI list, which is, that's pretty neat because basically if you look at the volatile markers that we analyze, you have the main glycosylated form that has been identified so far and that we confirmed after the 2018 fires that are excellent markers of smoke impact also here in the US, in California at least. Okay, so for each volatile marker, have the main glycosylated form. So by December of last year, all these compounds had been prepared and the isotopic analogs, and we didn't want it to be secret. So if you're in the research world, you work in a research lab, and you've been paying attention in the last few weeks, that's not news to you. But it's done by Toronto Research Chemicals, and it's available on the market. So which means that any lab with the right analytical capabilities can now generate results that are reproducible, that can be compared between labs. And that's a game changer. That's a big deal. So I couldn't resist. That's the geeky stuff here. That's these 6 pure compounds with their isotopic analogs, as we see them by HPLC MSMS in a standard. And so it's been now 2 months that we do that. So we have accumulated quite a lot of data by now. The main observation is that most often, at least with the last fire events, when volatile markers are high, glycosylated markers are high also, but it is not always the case. There is some exceptions. And so in some cases, you have relatively low volatile markers for high glycosylated markers. In some cases, the opposite. It certainly has to do with the efficiency of the grape defense mechanism. Earlier in the season, grapes in good health, good glycosylation happening. Later in the season, senescent grapes not working as well. We've seen a couple examples where the exposure to smoke happened actually mid-August, so not that late, and with almost no glycosylation. And the explanation, apparently, it was with Syrah that suffered a lot from heat waves. So guess what? If you have both cooked grapes and smoke, then they can't defend themselves. not much glycosylation happening. Still, the big unknowns that we will answer hopefully in the coming years is, so what are normal baseline levels by variety? That was our project for last year's, but so now it's pretty much in standby because there's no wines almost that we know for sure hasn't seen smoke at all, even the slightest amount. But we're ready to do that last year, or at least try again. How do levels of these glycosylated markers really relate to sensory impact? That's a big unknown. We don't even know if these compounds directly have a sensory impact. Hopefully, there will be good markers of the aftertaste, this lingering retronasal campfire that we're getting. But the only way to know is really to do sensory studies with adding them to wine. Third big unknown is how stable they are in wine. Every time that we looked at wines and that we monitored the volatile compounds over 1 year or so, we see increases that were so small that it was still within the uncertainty of the analytical method, like 10% or so. But maybe it was because bad luck, we chose wines that had low levels of glycosylated markers to start with. So what we're doing now is to select wines with high levels of glycosylated markers, relatively low levels of volatile markers, and we're going to monitor them, opening 1 bottle every 2 months for the coming year, probably 2 years. So we'll have better answers about that in the next months, or at least in 1 year. Okay. Okay, my contact info. Feel free to call me if you have any questions. And thank you for your attention.
Thank you, Eric. That was excellent.